December 22 is the National Mathematics Day and the Ramanujan Day. Related to National Mathematics Day, the Department of Mathematics organizes a national webinar on complex networks. In the real world, there are many networks such as computer networks, biological networks, etc. Dr. K. Satish Kumar Sir is present here to give us a lot of information about complex networks. Now I am entering to my duty. Welcome, speech. It is a great pleasure for me to welcome our respected principal, Dr. K.C. Frida. Teacher is always been our source of inspiration and motivation. A heartful welcome to you, teacher. I consider it is a great honor for me to welcome our resource person, Dr. K. Satish Kumar, Associate Professor and Head, Department of Future Studies, Karivattam Campus. He is also an alumni of our college. A warm welcome to you, sir. Next, I am glad to welcome Sri Adli Aswaram, SNCV Executive Member. Welcome, sir, to the webinar. Next, I glad to welcome Dr. Sunju S., our ICSC coordinator and the head of Commerce Department. Welcome, sir. Next, I glad to welcome Dr. Joel A., head of Chemistry Department and the former principal. Welcome, teacher. Next, I welcome Sri Murugan, Dr. Sarva, Apsana A., our Assistant Professor in Mathematics. Welcome, my dear teachers. And I welcome all the participants to the webinar. Thank you. First, I invite our principal, Frida teacher, to deliver the inaugural address. Hello, teacher.
Our chief guest, Dr. Satish Kumar from Kerala University, Program Coordinator Neelima, Interest Executive Member Aji Sir, IPSC Coordinator Soji Sir, HOD of Chemistry Department Dr. Jolly Teacher, other faculty members, Dr. Sanma and Sri Murugan from Mathematics Department, my colleagues and my dear students and research scholars from various institutions. Ma'am, good morning to all. Today, Department of Mathematics in association with ICSC is hosting a national webinar as a part of National Mathematics Day. The main objective of this program is to mark and honor the contribution of great Indian genius in mathematics, Srinivasa Ramanujan. Celebrations like this provide a platform for students to pursue the natural curiosity in mathematics and stimulate interest among them. Now, it also helps to develop the habit and skills to use mathematics to express the entire world. We are blessed with an eminent resource person to deal with a very recent topic, that is complex networks. I request students to make use of this opportunity and wish all the success for this program. With humble tribute to renowned mathematician, I officially inaugurate this program. Thank you.
Thank you, teacher. Next, I invite Aji Aswaram sir to deliver the felicitation. Aji sir? Sir is not in. So next, I invite Dr. Soul sir to deliver the felicitation.
Respected resource person, Dr. Satish Kumar sir, respected principal, Frida teacher, Sri Adli Aswaram sir, Neelima teacher, my dear colleagues from our college and delegates from other colleges, and my dear students. The IQAC of our college is very glad to know that the Department of Mathematics is organizing a webinar on a very relevant topic called complex network. I'm not very much familiar about the mathematical aspects of complex networks. Actually, I belong to the commerce faculty, and we are very familiar with one of the networks. We are usually utilizing that mathematical tools for decision making, like PERT and CPM. I'm not very much clear, and I'm not very much sure about the applicability of this complex network in decision making process. Anyway, what I'm trying to say is these kind of mathematical tools will be beneficial not only for the mathematical researchers and mathematics students. The mathematics is widely utilized by all other faculties, including commerce, management, science, etc. So, this webinar will be beneficial to all the students from all the faculty like science, arts, commerce, etc. In that sense, this kind of webinar will be very relevant in this context. With these words, I wish all success to this webinar, and I hope that the participants will be benefited out of this webinar. I know about the resource person. He's the head of the Department of Future Studies. He is very eminent. He's a very eminent faculty from Kerala University. His speech will be thought-provoking to all the participants. I wish all success to this webinar. Thank you, comment all.
Thank you, sir. I invite Dr. Joel Peter to deliver the felicitation.
Hello, good morning. ഏറ്റവും ആദരണീയ പ്രിൻസിപ്പൽ പ്രീത ടീച്ചർ, ഇന്നത്തെ നമ്മുടെ റിസോഴ്സ് പേഴ്സൺ ഡോക്ടർ കെ സതീഷ് കുമാർ സാർ, സർട്ടിഫിക്കേഷൻ പറയുന്നത് നമ്മുടെ മാനേജ്മെന്റ് പ്രതിനിധി IPS സാറും സാർ, IPSC കോർഡിനേറ്റർ സൂര്യ സാർ, introduction speech പറയുന്ന ഡോക്ടർ സന്മ ജി, പറയുന്ന മുരുകേഷ്, പിന്നെ മാത്സ് ഡിപ്പാർട്ട്മെന്റ് HOD മിനിമ, മാത്സിലെ അതർ ഫാക്കൽറ്റീസ്, നമ്മുടെ കോളേജിലെ ഫാക്കൽറ്റീസ്, അതർ ഫാക്കൽറ്റീസ് ആൻഡ് പ്രിയപ്പെട്ട കുട്ടികളെ, ഇന്നത്തെ ഈ വെബിനാർ ഗണിതശാസ്ത്രജ്ഞനായ രാമാനുജൻ ഓർത്തുകൊണ്ട് നടത്തുന്ന ഈ വെബിനാറിൽ എല്ലാവിധ ആശംസകളും നേർന്നുകൊണ്ട് കുട്ടികൾക്ക് നല്ല രീതിയിൽ വളരെ എമിനന്റ് ആയ റിസോഴ്സ് പേഴ്സണാണ്, നല്ല രീതിയിൽ പ്രയോജനപ്പെടുത്തി എന്ന് ആശംസിച്ചുകൊണ്ട് നടത്തുന്നു. നന്ദി, നമസ്കാരം.
Thank you, teacher. I invite Dr. Karna teacher to introduce our resource person.
Hello, good morning. Honorable Principal, Dr. K.C. Prida teacher, our guest, Dr. K. Sadish Kumar sir, Sri Aji SRM sir, Executive Member SN Trust, faculties, Sri Jolly teacher, Sri Soja sir, IPSC coordinator, and research scholars and students. It is my tremendous honor to introduce our speaker, Dr. Sadish sir. He is from Trivandrum district, possessing a brilliant academic record throughout his profession. He did his PG from Annamalai University, took PhD from QSAT, starting his career as lecturer in Department of Mathematics, Pondicherry University, and then to St. John's College, Anchal, and now as Associate Professor and Head of Department of Future Studies, University of Kerala. In this journey of career, he has held many responsible positions such as Principal Investigator to different research projects funded by UGC CSIR, Department of Science and Technology, Kerala State Council for Science and Technology, etc. He was the recipient of postdoctoral fellowship from Department of Chemical Engineering, Monash University, Australia, and Department of Physics, Pohang University of Science. Having just experience travel.
Thank you, teacher. I invited Dr. Sadish Kumar sir for the presentation.
Good morning. Good morning. Respected principal, Nilima teacher and other faculty in SN College, Varkala. Thank you for inviting me to talk on this complex network on this occasion. I'm really happy to be here in this webinar. Before that, let me ask you, am I audible properly? Like, am I audible?
Audible answer, audible answer.
Oh, so thank you very much. And indeed, it is a pleasure because I did my undergraduate and even a pre-degree course in SN College of Vakala. Like I spent almost 5 years of my life in that college. So basically, I'm from Attingal, near Attingal. Like I did my pre-degree course and undergraduate course, BSc course in mathematics in SN College. So I'm very much familiar with this college, and it is, I mean, coming back to a college where you spend a lot of time, it's really a pleasure. Like, so I've been there for 2 years back, also associated with some other workshop on data analytics, I think 2 years back or 3 years back, organized by the zoology department. So I was just there over there after 35 years back. So really a pleasure to be talking to people from that college. Because, I mean, you know, when you are a student and you spend most of your time as a young student to a college, so that kind of association will always remain. Even if you go abroad or if you study higher studies in many other colleges, that kind of association and mental association will always be there. Like, I mean, so it's a really pleasure to talk to people from the same college. Right. Thank you for inviting me on the outside, and thank you everyone for this occasion. Okay, today we'll be talking about the complex network. Mathematics, I mean, I will be talking about some of the applications of mathematics related to graph theory, like one of the mathematical subjects. Like mostly, why I'm talking about applications is that, like, you know, generally there is a feeling that mathematics is a bit difficult, or if any other subject, if you ask everybody else, like, you know, they will have an idea, like mathematics is something different. Everybody sees it as a different subject, like, and we all say that it is a queen of science. Mathematics has been applied in almost all branches of science and technology. It's a queen of science. But at the same time, but if others were asked to something related to mathematics, and they may be a bit scared, like I would say. Even Stephen Hawking has so said, if you introduce one equation to an audience, you lose strength from the audience because nobody like mathematics, like all the equations are there. Why is it so? I mean, I was wondering, like, why is it so? Is it not like any other subject, like mathematics? Maybe because we are dealing with very abstract ideas, but all these abstract ideas came from the nature, like any other subject. It is related to reality, like. Mostly the way I think it is the way mathematics is been taught. Like usually, mathematics students are taught like that. They start with a definition. After define something mathematically, like they keep on proving theorems, lemmas, and other conjectures, etc. Like no. So they may not get an idea why is it this definition? What is this definition about? Why can't it be defined in some other way? If you define in a particular way, you may get 240 theorems. Like if you alter the definition, you may get some other kind of theorem, maybe 500 theorems, or even less than that if you alter the definition. Like why? What is the justification for defining that? Like these kind of things we are not explaining properly. Maybe that is one reason why mathematics is being looked at in a different way. Like, but it has been applied any other subject. And another thing is for the students I am telling, like for the youngsters I am telling. For if you ask a chemistry student like what is organic chemistry, they may say that it is the chemistry about live beings or the chemicals associated with live beings. Even optics, they may say it is a study of light or something like that. But if we as mathematicians, if we were asked what is algebra, we might give an answer like it's about relations, set or whatever, but that may not be properly understood by others. Why is it so? If others can explain what their subject is, why can't we mathematicians explain what our subject is? Like mainly because the way we were taught, like about mathematics, we always start with the definition. Like what is the logic behind? Why do we define a particular way? Like that is more important. Like. That is one reason we may distance it from the other branches of science. Like people find it a bit difficult to associate with the mathematical thoughts, etc. Like, But it is all evolved from the nature. Like, if one subject cannot be dropped out of heaven. Like, if all other subjects, if we evolved out of natural phenomena, etc., this is also evolved out of natural phenomena. So, and we have to see it in that angle, like for almost all, and everything you have application in the other branch of science. So, just without saying that it has got application is not enough. Actually, you have to say what is application. And illustrate the application students should see. Then only that will get motivated. That is what I personally think. And there was I forgot his name, one professor from Europe. He has said the first paper a mathematical student is to be taught is mathematical modeling. All the mathematics students should be taught the paper mathematical modeling. Then only you should go about understanding higher mathematics or abstract mathematics ideas. And before going to that, I'll tell you, these are all for just freshers and young students, for undergraduate students. I'm telling, like, how do you prove a theorem? How do you prove something? Like, there are different ways of proving, actually. Mathematical proof is one among them. Like, see, say, for example, if you say that something we say, we can prove it mathematically. Like, usually we say that root 2 is irrational. Root 2 is irrational. How do you prove that root 2 is irrational? We have an analytical proof. We assume that if possible, root 2 is rational, right? Then we arrive at a conclusion. We arrive at a contradiction. So there cannot be any contradiction, no, from the assumption to the last sentence. So if the contradiction arises because of our assumption is not right, like, so that is a usual way. Or other people, we generally may call it as a pure mathematical proof, pure mathematics, so-called pure mathematics. But others call it as an analytical proof, analyze. Usually we say that A implies B, or when you write it like, A implies something, then implies something, like that, finally we get A. So ultimately that is a deductive principle. That is how we prove, actually, from A to B, like A. So this proof is the best proof. Mathematical proof are the best proof. Because if root 2 is, we prove that root 2 is irrational, it is root 2 will be irrational here in Kerala. If you go to United States, it will be irrational. If you go to any other part of the world, or it will be the same, like it will be irrational. Like, so it is something like universal. And it is independent of time also. It is root 2 is irrational in the morning, root 2 is irrational in the evening, and any point of time, root 2 is irrational. So that is the best proof. But there are questions about the kind of proof also, like, what you can prove. I mean, the other side, there is something called the empirical proof also. Like, so they question this kind of proof because if you say A implies B, how do you prove that? You cannot use any other information other than what is assumed in A. Only that you assumed in A can be used to prove B, right? So when you implies we prove, they ask a question like, will there be any new truth content, any new truth in B apart from A? There cannot be anything, no? Because you are not using anything else. You say that you only use the concept A, then you start proving implies, and finally you arrive at B. So to arrive at the B, you only use the concept in A, like, right? Only use the concept in A. So there cannot be any new truth. So they question, if you prove this kind of thing, no new knowledge will be arrived. No new knowledge will come for humanity. Like, if you prove like this analytical proof, like A implies B. Suppose if you prove B implies A also, both A and B are same. If and only if B, both A and B are the same, right? So the truth content in A is same as the truth content in B. So new knowledge is not coming out. And even empirical science even questions like this kind of proof. But I'm not saying this way of proving is not good or bad or anything like that, because this is the best proof we can ever think of if you want to prove something. But they question like, all the human knowledge. We say that axiom 1, we know this. Axiom 2, we know. All the human knowledge at present, what we know, if you take as axioms, then you start proving it. Can you get any new knowledge? New knowledge? That is the question. Can you get new knowledge? It is not possible, actually. But I mean, and in 1920s, Hilbert, the mathematician, those who have studied topology, etc., they might know Hilbert space, etc. Like the mathematician Hilbert and others, they are of analytical proof. They are favoring this kind of analytical proof. They believed that the whole truth of universe, this world, can be proved from few principles, like few axioms. You list a few axioms, like axiom 1, we know this, axiom 2, this. From few set of axioms, they believed that everything else in the universe can be deducted. So from that we can prove all the knowledge, like, we only need a few axioms. That is what they believed. And that is called the Hilbert program. But in 1932, around the 30s, Gödel came and proved Gödel's incompleteness theorem. He himself is a mathematician. That's a funny part about it. He proved, suppose if you assume a set of axioms, like A1, 2, 3, a set of axioms. If that contains everything, all the knowledge, like, nothing, if it is complete, like if the whole knowledge, if it is contained these axioms, then there will be contradiction among them. You cannot have contradiction among two axioms, no? We define like a group. Group has got 4 axioms. So if the second axiom cannot be contradictory with the first axiom, right? When you have axioms, they should not be contradictory. So the Gödel proved that when you have a set of axioms, if it is complete in the sense if contains the whole knowledge of humanity or the whole truth about the universe, if it contains in that, there can be contradiction. Like he has proved it mathematically. And if you assume that all the set of axioms, the number of axioms you have taken, the set of axioms, if there are no contradiction among them, so then he proved that there can be more truth. Like, there is some other truth which is not in this axioms. Like, so this kind of people, who believed that everything can be proved this way, they go to this solution. You know that Bertrand Russell, we call him like a mathematician and a philosopher. He is also of this school of thought, and finally he changed from this kind of idea, like, he became a philosopher, like. So this is mathematics, like, this is one way. It doesn't mean that mathematical proof is bad, like, this is the best proof we can ever think of. Then for scientists, they prove empirically. Like, how do they prove empirically? For a chemist, actually, they prove if acid and base taken together, it will form salt and water, right? If a combine acid and base, it will give salt and water. So that is a theorem for a chemist, actually. How do they prove, actually, acid and base combine together, salt and water? So how do they prove? They go to the lab, they add acid and base together, then you check what are the products, like, then they get salt and water. So that is how they prove. That is how they prove that. So they do an experiment. So, but the problem is that by doing experiment, we cannot prove that. Second day, if it goes, what is the guarantee that it won't go wrong in the second time? So for that, they repeat. They may repeat it 10 times. 10 times, if they repeat the experiment, if they get the same result, they will believe that, okay, it will be true forever. But it can go on the 11th experiment. Or even if you have repeated this experiment 1 lakh times, you cannot be sure that it is true, because the next time it may go wrong. Like, so empirically, they cannot prove everything perfect. But more and more times, if you do some experiment, you will get the belief that the confidence that it is be true will be more. Like, so that is what empirical proof. Then there is something called statistical proof, actually. So we say that smoking is injurious to health, or smoking causes cancer. How do you prove? Can you prove analytically, like smoking? This by equation, can you prove everything that smoking causes cancer? Like, you cannot. You cannot analytically prove. Maybe possible, but so far nobody has proved it, like with equations and all. So smoking causes cancer. So that will be proved statistically, like, the statistical evidence, like with the testing hypothesis and all. You have around 100,000 people, 1,000 patients. Out of 1,000 cancer patients, if 900 are smoking, then the chance of smoking being the cause for cancer is more high, like with the person, the confidence you have. So that's some kind of statistical proof. So you cannot prove everything mathematically, but there are other ways of proof also. But the other ways of proof, you cannot be sure. So mathematical proof, you can be sure. So that is a good thing about mathematics. And another thing, I think, it is most of the ideas coming from to the mathematics, it's actually not proved by mathematicians, or it is by other people, other kinds of people. Like, say, for example, you might have heard of something called the wavelet theory. Or at least you might have heard of Fourier transform, right? All the students, Fourier transform. You have Fourier series, Fourier transform, etc. Fourier transform, if you take, actually, Fourier transform will show you if there is, I don't know whether you are familiar with that, if there is a time series or a wave or something like that, if Fourier transform can give all the frequencies in that wave. In sine wave, we have one frequency, right? No, one wave, only one wave, sine wave. It is one wave. Now, 2 pi is the wavelength, right? No, 2 pi is the wavelength. So the frequency is 1 by 2 pi is the frequency, sine wave. But in some waves, like there may be more frequencies, like more this one combined together, like Fourier transform will give all the frequencies, but it doesn't give where the frequency occurs, like at the beginning or at the end. So then came up with the wavelet. Wavelet theory, now there is a mathematical theory of wavelet, but it was originally brought up by a petroleum engineer. He wanted to know whether will the petrol be in the bottom or not. So he sent some sound signal, got the feedback again, then he analyzed, and that is how it was. So many mathematical subjects were arrived out of other things, right? So like now we have something called a graph theory. So I'll be talking today about a graph theory. Yeah. This graph theory, there are a lot of applications also, like, I'll be talking about some of the applications. Maybe for the final year undergraduate students, BSc students might be learning about the graph theory, like, So I'll be talking about, mostly I'll be showing a lot of examples, applications outside of mathematics, other branches of mathematics. My PPT visible now? Is it visible now? I shared my screen. Is it visible now?
Yes, sir. Yes, sir, visible.
Okay. So I'll be talking about complex network. So how is it connected to mathematics? Like now, I mean, there are a lot of applications, almost all branches of science. Even you might be wondering, like, Saddam Hussein. I mean, there was a war, with America and the Saddam Hussein Iraq actually. So after the war, Saddam Hussein went hiding. Nobody knew whether Saddam Hussein was there. Like, he went hiding. Do you know that American government arrested Saddam Hussein just by using the theory called the graph theory, a mathematical subject like graph theory? They used the graph theory to arrest Saddam Hussein. So you might be wondering the applications of mathematics. Like, even for these kind of things, there are applications. So a lot of applications for mathematics. To get excited, to get motivated, you should know some kind of mathematics. Now, the good thing is that you can Google, you'll get all kinds of information about mathematics, all the applications, etc. Okay, so I'll be talking about this kind of thing. So what is a graph? What is a graph? Maybe the first year students, they may not be knowing what a graph is, but I'll tell you a little bit about graph theory. For master students and others, they know what is a graph. Actually, a graph will have two things, like, two things, like, there will be nodes, like this is called a node, or mathematicians call it as a vertex. This is another vertex, like another vertex. These are all vertex, like, they call it as vertex or a node. Then there is a connection between these two, like this is called an edge. Sometimes this edge will be directed, then you put an arrow like this. Otherwise, we'll have a line connecting these two. So these are called edges. So what is a graph? Graph is a pair of two things. One is a set of vertices and a set of edges. Edges means the lines connecting between these two. This graph theory comes under the category of discrete mathematics. There is something called continuous. This one is discrete, like 1, 2, 3, etc. If you count like that, these are all discrete. But a segment of a line segment from 0 to 1 is a continuum, like, for between any 2 points, we can find another point. So it is a continuous one. But 1, 2, 3, if you count, it is discrete. So this is a graph. But sociologists call it as a network. Mathematicians call it as a network. Graph. Whereas sociologists call it as a network. Both are the same. In social science, there is an area called the social network analysis. It's an emerging area like social network. Actually, it is graph theory, pure graph theory. But they don't apply this kind. They don't prove theorems or anything, but they apply it and get useful information. So something called a network, and so both are the same. I just wanted to convey that network and graphs are the same, right? Then okay. So this graph, there are a lot of graphs actually. So for BSc students or MSc students, you might be dealing with the graphs with the maximum 100 nodes, right? 25 nodes or 100 nodes, up to that much. But in network analysis, what I'm talking today, like complex networks. In complex network, the number of nodes will be huge. Like, it's not like 25 or 100 or anything like that. It will be a huge number of nodes, like a huge number of nodes. Not only that, the relation among them will be very non-trivial. Like they will have non-trivial relations. Like it's not very. I mean, even if you take a triangle, this is also a graph. Like this is one node, this is another node, this is another node. So, and you can have one more node if you want. Like this is a graph. This is a graph, but this is a very simple, easy graph. Like in complex networks, complex graphs, the number of nodes will be huge, and apart from that, the relation among them, the connections among them will be very complex. It will be non-trivial. So such graphs are called complex networks. And there are a lot of applications. Suppose we are all friends in Facebook. Now we all use Facebook, no? So everyone, like me, is a node. You are a node, and everyone among us is a node in the network. But all of us may not be friends through Facebook, no. Some of them are friends. Myself and some other, maybe one of you may be a friend through the Facebook. If there are through the friends, if they are friends, we'll put a line among them. So let us assume that this is me and this is you. Like we are friends on Facebook. Then there will be edge. But I am not a friend of this person. Like this person is different. I am not a friend. So since I am not a friend, we don't put a line. Like. And here there are few participants, they don't have any friendship through Facebook right now. So that will have a network. So this kind of network also we can analyze using this mathematical concept, the mathematical theory. So you may ask, why do you want to analyze this? This will give a lot of useful information, like useful information. This kind of network, if you analyze, lot of information is there. Even people doing a lot of advertisement, also using this kind of network. So, say for example, first when mobile phone came to Kerala, this society, not everybody had this kind of smartphones. Now most of the people are having smartphone. Now, how do they got diffused into the society? Smartphone is a new technology. How does it infuse into the society? Maybe one person might have had a smartphone. So the other person thought, okay, by seeing his friend, after seeing this, he thought, okay, I will also buy. Because the connection between these two people, like, So since this person is having a smartphone, his friends might, seeing this, might have bought this. May not be all the friends, but some of the friends might have bought it. So that is how the technology is diffusing into the society. They also use this kind of graph. Technology diffusion in a society. How do you identify technology diffusion? For that, and they will use this kind of graph theory. Even in Facebook friendship network, like one person is displaying something about some technology or movie or something. He might have written a review about a particular movie at the cinema in Facebook. Watching this, some of his friends may also go for that movie, like only because they have seen this advertisement. Advertisement, only because of that only they have gone for that movie actually. So that network matters actually. Who are all connected? Like it is about all connections. So this is about network, and in sociology, and there will be a lot of this kind of network. They call it as a social network. Because in graph theory, mathematics, we call each node as a node or a vertex. But in sociology, we call it as an actor. One actor, another actor, they are connected. Like they are actors. Though they kind of do analysis on this kind of network, and that branch is called the social network analysis. Social network analysis, and I have said the main thing is nodes and edges in a graph. Like most complex systems are graph. Like there are a lot of things we can model as a graph in the society. I mean, I'll show you a lot of examples today, actually. So this is a scientific collaboration. This is a researcher. This is a researcher. He is doing research in agent-based modeling. One area. Actually, this is a real network, not something which I have drawn, like a real network. One person has written, he is working on agent-based model. And there is another person. He is also working on this area, and they have combined together, written a paper. research paper, we will publish research papers. So if two persons came together, found something, and they publish commonly, then there will be an urge actually. So this person and this person combined together publish something. That you say there is an urge. And this person did not publish. So they did not publish anything common. They are not co-authors. There are no urges, right? Then agent-based model, one person, mathematical ecology. There is an area called mathematical ecology. So one person from agent-based model and another person from mathematical ecology combine together and publish a paper. So there is a new area. Right? Then they publish another area like statistical physics, how the different areas are connected, then structure of RNA. So these are all connections. Like this collaborative research also forms networks, new network. This is about the business. Then in the introduction, I forgot. So they were talking about the business, commerce and all. Even in commerce, actually, this kind of graph theory arises. These are all biotech companies in the US in 1991. This is a biotechnology company. This is also a biotechnology company. I mean, they produce some biotechnology products, like all the biotechnology companies in the United States in 91. This is an example, like this network. So what does it mean? Like there is a line. This node, this company and this company has got an urge, actually, common urge. What does it mean between these two? Urge means they have some kind of research collaboration or business collaboration. Say for example, this company and this company has they have a research collaboration. That is why we put an urge, a line connecting these two actually. So there is an urge. So whichever company, but there is no direct connection from these two companies. That means they don't have any kind of research collaboration. They don't have any research collaboration or what you call or business collaboration. So there is no urge. So that will also form a network. This will also form a network. People analyze this kind of networks, like get useful information. Say, why do you want to analyze this network? Say, for example, if I have a biotechnology company in Kerala or India, I want to have a collaboration with some biotechnology company in the United States. Which company I should go for? I should go for the best company, So then I want to know which is the best company. So those companies which has got a lot of connections will go for that. So that is one area, like the applications. This is a genetic interaction network. Genetic interaction network. You might have heard of, I don't know whether you might have heard of it. There is something called the protein network. Protein network. The DNA is the shape of DNA like a helical shape, like a ladder, a twisted ladder, like in a helical shape. So DNA, you might have heard one particular gene may be the cause for one particular disease. One gene is the cause for one particular disease. So you developed some drug, you developed some medicine to alter that gene or something, then you can cure the disease, right? But the problem is that this gene might be connected to so many other parts of the world. So if it is connected to so many other parts, if you alter this, if you modify this, that is going to affect all other parts also, like all other parts also. So that will affect. Then usually the biologists, what they do is they do a pathway analysis before developing this kind of medicine. Like they also do this kind of analysis, genetic interaction network. This is actually a protein interaction network. See how complex it is. It's a graph. It is basically a graph, but it has got a huge number of nodes and a huge number of connections also. And one area people working is that you suppose you want to find the maximum degree. The degree means the number of connections it has got. This node, what is the degree of this node? It is 3 and 3 here. So 6 lines are connected to this. So the degree of this node is 6, right? The degree of this node is 6, right? So not 66, it is 6. Okay. 6. Now number of nodes is 6. So that way, if you want to find which node has got a maximum degree, if you want to, can you do this manually? It is very difficult. So some people are finding new algorithm to analyze this kind of network. So algorithm related to this network algorithms, that is one research area. Like At the end, I'll give some simple research problem also. Even undergraduate students, we can try those things. I'll show some. And some of you might have already studied in operations research or something like a transportation network, transportation problem. Suppose if you want to travel from one place, right? One place, if you want to travel, maybe from this place, if you want to travel from this place, you will want to travel some other place. Maybe you want to go here. Like, you want to go here. Is there any direct flight? Direct flight from here? No, there is no direct flight. You may have to go to some other place, some other place, some other place. Then you have to come over here. Then they want to know which is the shortest path. Shortest path. You have to go to one place to another place. And if there is no direct flight, then for that also you use this kind of network, transportation network. Like they do, there is an algorithm for finding shortest path also. Like sometimes you may be wanting the cheapest route. It may not be the shortest, but rate-wise it is cheap. So you may travel more, you may spend more time, but you want, for all these purposes, we use this kind of network. This is internet itself. If you look at it, you feel like it is a galaxy, you know. It is something like the galaxy, or what, all the stars on the sky, like a galaxy. But it is not galaxy, it is all the internet. Each node is a computer. This is a computer connected to internet. This is another computer connected to internet. So this is connected to another server. Sorry for that. So another server, then it is connected to another server. And the computers are connected in the internet, like servers. If you take all the servers, then it is like a huge network. It is called the internet network, like web network, web graph. Some people call it as a web graph. All these are connected. So they also analyze this kind of. They also analyze this kind of network, like. Why do they want to analyze? Because suppose you assume that this is Google website you go, no? So that may be put that the data is there in one server. This may be you. This is you. This network is you. Okay. So this way, when you type on the browser like google.com, it has to reach this computer. So it may be going from this computer to this computer, like that. It is going to this computer. So what happens if one node is down? If that computer got down, it is shut down. Then you cannot reach this or no. So then you have to find alternate to do. So they want to identify the major servers is always up and all. For that they analyze. You see how complex it is. Like it is very difficult to analyze usually. Like usually this kind of network. Like for all this purpose, we can do this. But the analysis and the theory you're using basic mathematical graph theory, like all the graph theory and this kind of concept you use. It's an interesting area. Like if you are doing your masters, you can write your MSc project on this actually. And there are a lot of research papers. Some papers are tough and some papers are easy. Also, you can do that computational mathematics. And historically, how this area was evolved. This was started way back in 1736, long back actually, 1736. You know the mathematician, French mathematician Euler. French mathematician Euler is the first person who started using this kind of descriptive mathematics, the area called the graph theory. Right? There was a place called Königsberg. Königsberg, this place, Königsberg, if you look at Google map, even if you type Königsberg in Google map, you will see the place. It is still there, that place. It is one among the separated country from Soviet Russia, old Soviet Russia. It's that is near to Russia, right? This place, Königsberg. And there is a river passing through. A river is going by this. And the blue one is a river, like. So the blue one, there are bridges. This is one bridge, and each green one is a bridge, right? It is a bridge. This is a bridge. This is another bridge. This is another bridge, and another bridge. The question was, you start from this island. You start. You have to go to this island. This island. You have to visit all the islands. Then you have to come back to the original place. But the condition is that you should not cross a bridge twice. If you have used one bridge, say for example, you have used this bridge you have to use to cross this to this island. Then you cannot go back the same bridge. You have to go by the other bridge, from some other bridge to this place. So then the question was, is it possible or not? So he diagrammatically converted into this figure. Then he converted it into a graph actually. So this is an island. This is another island. Each one is an island. Each one is an island. And each line is a bridge connecting to these islands. It is a bridge. Then it is a graph. Then he could easily solve by looking at the first figure. It is very complex actually. When it was modeled as a graph, it is very simple. You can analyze it and get to know is it possible. So that is how he analyzed it. This is the origin of this graph theory. So it started in 1736, very old subject, but now lot of application, protein network, up to protein network and other things, lot of application. Then you might have heard of something like a 4-color problem. 4-color problem. It was solved in 1852. Like 4-color problem means, how many minimum number of colors required for making world atlas, the world map? How many colors are required? You cannot use the same color for India and Pakistan, no? Pakistan, you have to use one color. India, you have to use another color because there is a border. If you use both the same color, you cannot distinguish the border. So at the same time, we can use the same color for India and America. In the United States of America, like we can use the same color because we don't have a common border. So in that sense, how many minimum colors are required? It was also mathematically solved a 4-color problem, like in a world map pattern. And there are a lot of applications for this kind of graph theory, particularly in social science. And this I'll just skip because this is mostly related to sociology and of applications of this, the historical evolution. I'll talk about 2 major concepts in this one, in sociology. Like one is called strength of weak ties. Another concept is called small world phenomena. Small world. They say this world is small. This world is small. And another is strength of weak ties. And there is something called the social capital in economics now. Like you know, if you start some business, you need a capital money, to start a business. Now, the money is not the only capital. You can have social capital also. People associated with you, people have connections with you. That is also a capital. Like you can sell to them. Like that is also a capital. And in 1967, a professor called Milgram. Milgram is a psychologist, and he did an experiment. What was the experiment? At that time, there was no email or anything. So in a village, he wrote a letter and asked his to pass on to some particular person in the village. He put an address in the letter and gave it to that person. But you cannot go directly and hand over to that person. You have to give to your friend. Your friend will give to his friend. Finally, it has to reach that person. He did an experiment. Not only one letter, several letters he put to several people. Like then he found out that on an average, with the 6 transactions, you can reach anybody. Like you have to give to your friend, he will give to his friend. Then how many transactions are required to reach the final person? And it was identified that on an average, 6 transactions you can reach anybody in the village. That means on an average, in some cases it may be 5, in some cases it may be 10. You need 10 transactions to reach that person, right? So 10 transactions. So, but on an average, it needs only 6. That is called 6 degrees of separation. That means the world is very small. With the 6 separation, everybody knows everybody else actually. You are all from different places. So I don't know, some of you, I don't know directly like, but if I ask like, I know one of my friend, he may know some other friend and his friend, like that if I trace, on an average, maybe 6 degrees of connections, we may all be connected like as friends. Like maybe not the direct friends, but indirect friends, like friends' friend, like that we are all connected. It is called a small world phenomenon. And based on that, there was a film in 1993. And this mathematical theory, there was a Hollywood movie. The name of the movie is 6 degrees of separation. There was a movie based on this mathematical theory in 1993. And there is something called a strength of weak ties. Weak ties, the strength of weak ties means suppose you have a graph. This is a graph. This is a graph. We are all friends. I am connected to this and we are all friends. And this is friend. And I may be a friend of this person also. I may be a friend. But this friendship is not very strong friendship. I know him, just a weak friendship. And usually in our personal experience, we don't count those people, no? We only count our strong friends. But sociologists say that this weak friendships can also give a lot of lot of what you call benefits to you. So don't ignore the weak friendship, weak friends. Like, they also count a lot, actually. They also contribute a lot for your success. I mean, this theory has been applied to very many different areas, like citation network analysis, lot of application, like researchers use this for citation network, co-author network. I have shown you earlier, there are something called a terrorist network. Terrorist network. There are a lot of research on terrorist network also. Sometime back, you have read, the government of India arrested somebody from Bangalore. He was a software engineer, was arrested, saying that he has got a lot of connection with the terrorist organizations. How does the government know this person has got a connection with this terrorist network, terrorist organization? He is working in a company. You even might have identified, he was arrested because of the T-shirt he was wearing. He posted in some of this site actually with a photo, where he was wearing a particular T-shirt. Then they searched for that. So this kind of networks, through terrorism, they have connected, and they have some kinds of connections. And through this network also, the people are doing a lot of research, identify the complexities or the peculiarities, the characteristics of this network. They analyze, actually. They also form a network. And in connection with, I would also say, one postdoctoral fellow from one university, after his postdoctoral fellow, he did some kind of data analysis and predicted where would be or when would be or at what place would be the next terrorist attack in Afghanistan. He predicted some place near Kandahar, in between Kandahar and another place. Exactly at that place, after some time, there was a terrorist attack happened. People are working on that. That's one area. And I said for Saddam Hussein, after the war, went hiding, actually. So nobody knew where Saddam Hussein is, where somehow Saddam Hussein is, actually. So the American government wanted to trace him. So because he went hiding, his ministers in his ministry, they also went hiding. So most of the prominent people went hiding. So what the government did, what the agencies did is, they constructed a network. Saddam Hussein friends, so they are all connected on network. And they're his friends, like that they construct a network. And they somehow catch hold of the remotest node. Through that, they traced back to this fellow. So that is there, then there is something called the economic network, economic network. And in economic network also, they use this theory, family network, organization network. Even after BSc, you can start a company doing organization network analysis. Organization network analysis means in a company, actually, suppose I am working in a company, head of a software company. Under me, maybe 16 people are working under me. All these 16 people are reported to me. So they are connected to me. I may be reporting to my supervisor, superior officer. So there is a network structure. People analyze this kind of network, that is called organization network analysis. Why do you want to analyze this network? Because if you analyze, you'll get to know who are the most important person. Maybe an HR person is very important person in the company. So his character should be very good. So only then the company can profit out of this. Otherwise, if the company HR is a very rude person or a very short-tempered person, so it will all collapse. Then there are something called the sports networks, sports network. They also use this kind of thing. Sports network, you might have heard, I don't know, maybe you might have heard that Australia using mathematical theory to win the cricket match. You might have heard of And in sports also, they use a lot of networks. In Europe, there are a lot of football clubs. And one season, one person may be moving from one club to another club. Then there will be a connection that they analyze this kind of player transfer networks. Actually, it is graph, player transfer graph. They analyze it to find who will win in the next season. They're kind of doing it. Then a protein network. There are a lot of applications like, in the graph theory. I mean, see, as a student, when you're in the first class, if you go through all these network applications, then you will be motivated to study the graph theory. No? Otherwise, you just start with the definition of graph theory and start proving theorems. You may not be much interested. Like, no, it has got a lot of applications. Right? That is what I wanted to say. And another thing is that even if you walk through the sand, you will be creating a network. Suppose you are walking through the sand. Now, people are walking through the sand, it is creating a network. This is one, like, it is creating network. Like, almost everywhere networks, like ingredient networks and other things. I will show some of them. Now, sports, if this person is passing football to this person, we can say they are connected. Like, so football, you can have a dynamical network where a network which is a network where which is changing with the time and all. In butterflies won't lay egg in all the plants. No, in botany I can say one example. Like, one particular species of butterfly lay egg in one particular species of plant only. They don't lay egg in all the plants. Like, they select the particular plants. So if this butterfly lay egg in this particular plant, they are connected. Like, there also you can make a network. Like, see, for example, as a students, botany students or mathematics students combine together, try a network of butterflies and plants in your college, like in SN college. I mean, you have a wide ground and other things, lot of plants are there. I mean, if you go and identify what are the species of butterflies there and which butterfly lay egg in which plant. So like that, you can create a network in the campus, like, right? In the campus. Well, that will be a good thing to do, like this one. This is a political blog. Political blog means actually we write something in politics, about other parties, comments, political comments, and we make in political blog. So then the blog, actually, if you write something, the others will respond. Like, that will also form a network. Like, because in politics, we'll always talking about our own party. Like, that is why these are separated, two things. Like, that is also an application. Organization network, I said, in a company, there is a hierarchy of structure. You go and analyze it. There are companies doing this kind of organization network. So they are called organization network analysis. You can do that, actually. Just a BSc student can start a company on this, actually, organization network analysis. A startup company. Yeah, this is a Facebook friendship network. Like, these people are connected through Facebook friendship, and these are our Facebook pages. They don't have any friends in Facebook. Like, that is also a network. Like, the people analyze this, actually, who is having most of the this. This is an ingredient network. Ingredient network. So, I mean, what is an ingredient network? If you add two things in same dish, they are connected. Coriander and chili. Coriander, chili, salt, all the ingredients you take. Coriander and chili are connected because they add it together in a recipe. In particular recipe, if two ingredients are added in any of the recipe, any of the dish, then they are connected. So you can have a network out of this. This is a Western recipe. That is why all the Indian ingredients are not there. It's a Western recipe. Similarly, you can have a network of sambar. In the sambar, you have a graph, actually. So you can create a graph of sambar, all the ingredients connected to that and all. Okay. So ingredient network, people are doing research on this, actually. So what do you want to analyze this? Suppose if a grocery shop owner want to keep items, like which are the items they want to keep on this. For that, also, they do this kind of analysis. And another thing is, these are the people in the White House when Ronald Reagan was in power. When Ronald Reagan was the president of the United States in the 80s, these are the people in the White House. So two people are connected. This person and this person are connected because he has once sent an email to this. Though two people are connected only if they have exchanged emails. That is how this network. So when you analyze this, these people have sent a lot of emails. Like, these people also have sent a lot of emails. That means they are the powerful people in the network. Powerful. The one application of this graph theory to identify the most powerful person. See, for example, even in your class, we can have a network. Class a network. See, one teacher say, okay, we will have an examination next Wednesday. Our class test will be next Wednesday. Immediately after that, you start saying, oh, Wednesday is not convenient. Wednesday is not convenient. We'll have it on Fridays. Teacher, Friday teacher. You all say, no, it's a common practice. Whenever the teacher says the next examination is on Friday or Wednesday, we all will, as students, we'll all say, oh, Friday is not convenient. Friday is not convenient. When, okay, finally it will be fixed. How does the examination will be fixed? There may be one dominant person in the class, no? He is the dominant person. In the class, he has got a lot of friends in the class. He says he may not be the most bright student in the class. He may not be the most bright, but he is a very prominent person. He says, okay, we'll have it on next Thursday. Then everybody else will agree, right? So to identify the dominant person in the class also, you can use this kind of thing actually. He will have a lot of connections. When he goes to canteen, his friends will also go to canteen. When he goes to post office, his friends will also go. So there may be different, all are friends in a class, but some are more close actually, more close. So this group of people will always move together. The other group of people will always move together. So they are called clusters in a graph. So to identify the most prominent person also you can use. There are different ways we can identify this kind of centrality measures So this is the same graph. Degree means the maximum connection actually, D, the graph D. So what is the degree of this node? The degree of this node is 1. Degree of this node is 2 because there are two connections, right? Connections. So like that, I can identify the degree of each node. And so most of the highest degree, these red color nodes are the highest degree graph actually. This is from Wikipedia. If you go to Wikipedia, you will get the same graph actually. And there are a lot of other, there is something called the closeness centrality. How close actually. So if close means this node is close to most of the other nodes actually through the path. So if you consider as a degree, then these are the prominent one, the prominent nodes. I mean, there are different kinds of centrality measures. And those who have studied the graph theory, you know that every graph can be converted into a matrix called adjacency matrix. Adjacency matrix. So this adjacency matrix, when you have an adjacency matrix, you can find eigenvectors and eigenvalues. Well, eigenvalues can also be considered as a centrality. So highest eigenvalue centrality measure you can take of this, this one. So this is also the highest eigenvector centrality. I mean, that also can be, I mean, you know that when you go to Google, you type something for searching. The most appropriate will come first. The second approach, how does Google know this is what most appropriate for you? That is called, there is something called a page rank algorithm. That is also one of this kind of centrality measure. The page who was in Google developed an algorithm. So that is called page rank algorithm. They also developed something similar to that. I mean, a lot of applications also. I mean, about this. Yeah, this has got a lot of, say for example, if you want to place a post office in a town, where do you put the post office? It will be the center of the city, so that it will be convenient for the others to come. If you put in the remote part of the town, it will be most inconvenient. So post office, this one will be, they consider closeness centrality. It should be closeness centrality, highest closeness centrality. Suppose if you plan to build a waste treatment system, that you will put it only at the remotest place. Otherwise, it will be disturbing to others. Right? So there are a lot of applications. I mean, we are also doing a lot of research on this. I won't go much into that. May not be much interest to you, but I'll just say, I mean, this work actually board internet network. This is actually an application in commerce or management. There is something called corporate management in commerce subject or management subject like corporate management. Every company has a board of directors. One director, one company may have 10 directors. So they are all connected. Another company may have 10 or 12 board of directors. Maybe one person may be sitting in the board of both companies. Then they are connected. Actually, this figure is the company network of Indian Stock Exchange. NSE, you might have heard of NSE listed companies. of India. So we took data from that and found a network and we analyzed it, which we have published as a research paper in this journal called the Social Network. So basically it is graph theory, but we applied to a commerce subject or a management subject. He is the student who did this work actually. His name is Prem Sankar. He is very active in social network and in India, he is the most prominent person. This R.A. Shah. He is in the board of several companies. He is a very prominent person. His name is R.A. Shah in India. He is a very powerful person. He is sitting in the company of so many companies. He's a board actually, around 23 companies or so. He's a board member. So this kind of who is the most prominent people under, we can use graph theory and identify actually. This is road network. I mean, this is a road network near Cochin Metro, like now all the roads are connected. Now, if you go to Google Map, you can construct the road network. So I'll say maybe one BSc student in SN College, they can do a road network analysis of Varkala or Sivagiri actually. So when Sivagiri festival is coming up, there are a lot of vehicles will be coming. So how does people come? There may be some bottleneck actually. Some places there will be a lot of traffic congestion. So you can identify where the most of traffic congestion would occur like by constructing this kind of network. See, in this network, so if a person from this place want to go to this place, all they have to travel through these junctions now. So these junctions will always be congested, like then you can construct a new road. That and all you can use graph theory to identify that. No would matter. This is also again in commerce actually. Commerce or business. These are the something called mutual fund. These are all mutual fund. The blue notes are mutual fund. If you invest in mutual fund, they will buy shares actually. They will invest your money to buy shares from other companies, right? So if you invest in this mutual fund, they will buy these shares. If you invest in this mutual fund, they will buy these shares. So that will form a network. Like if you analyze this, you can know which company you have to invest for benefit and all. Sentence also you can construct into network. Like I was continuously talking. So till now, this I can convert into a network. Say for example, on sentence you take, I am writing a letter. I am writing a letter. I am writing a letter. This you can make a network. So I will drop all the word I am and all will drop because these are common words. Writing I will take. So the ing I will remove. There are softwares for doing this. This is called a parsing. So I'll only take the word write, then letter. So two words are there, write, letter. So they are in the same sentence, so they are connected. If two words are there in the same sentence, it will be connected. Like that, you can make a network. This is called semantic networks. And these are the networks of all the Independence Day speeches of the Prime Minister of India. Like this is in 1947, the speech when India got the first the first Independence Day speech after the independence. So the speech given by Pandit Jawaharlal Nehru, the speech. The most common, the most prominent word he used was in the talk was India. That is a large node. And today, these are the two words he repeated very often, actually. This is the speech given by the Prime Minister in 2014. Like. So these speeches are there on the internet. You can download, put it in software, it will construct graph and all. You can even do the mathematics of this. You can do a lot of mathematical analysis with these kind of networks actually. I mean, for an undergraduate student, even for a master's student, if we do this kind of analysis, that is going to be a good work actually. Is it not? It will be a good work. I'll also show one software at the end actually. By that, I'll finish this talk. And this we have analyzed. What is the purpose of doing this? If you analyze this, we'll come to know what is the policy shift of the government. Like, when we analyze this, we have found that when India got and all, at that time, the government of India had a very, very well-planned long-term policies. Now it is shifted. But at that time, they forgot, they did not give much importance whether it can be implemented or not. Whether implemented or not, they did not give much attention. But their plans are very well defined, long-term policies. Now now it has shifted. Now most of the this one are short-term policies, short-term plans. But now the focus is on the implementation side. It should be implemented. That is the focus now governments are giving. This is not for one particular party. Almost all parties, they are doing the same. So there is a policy shift among this. On this I can do. And player transfer network actually. You, as students, you know all the IPL teams, no? Bangalore, Delhi, these are IPL teams. In one season, one player may be playing for one team. The next season, they may go to other, because it is there will be what we call tender process. No, they will be this team will give more money than this company, so they will switch over to this. This is called player transfer. There are a lot of player transfer network. If you analyze this, you can predict who is going to win in the next IPL. You can do that actually. We also did some time back. One of the students in our department did that, and we predicted this team will win. But whom we predicted came only on the third position. Like maybe we don't have enough data. Or we consider each player as same. Like it is not same. No, if a prominent player is shifting to another, we have to give more weight. Then we have to consider it as a weighted graph. Like you can do that actually. You can do. I mean, there are a lot of research papers on this also. This is Twitter network, like a Twitter network. I mean, there was some time back, some girls and boys went to a pub in Kerala at night and had a beer or something. Then the local people protested. They were beaten up. Then against that, there was a protest. It's called a Kiss of Love. I mean, they put, it's not like a protest done by the political parties. These are the protests done by the youth. What they did is they put a post in the Twitter saying that we are going to protest in a particular day on Marine Drive in Cochin. So this tweet will be retweeted in Twitter. This is the retweet network. We downloaded all the data, we analyzed, and we even published on paper using mathematics about the protest. You can also do. After in Kerala, that protest was went over, subsided. There was a protest in Delhi actually. So this is the tweet that caused the protest in Delhi. So that has been retweeted by so many people. See how this mathematical theory is connected to even with this protest, you can make a network. You can make a graph and do mathematical study lot of. And I said in Google, you have PageRank algorithm, no? PageRank algorithm. So PageRank algorithm was first, actually, the basis of that was developed by Ramanujacharya in 1964. He was a scientist in Indian Statistical Institute. This is a research paper. You can download it in net, actually, professional experience. So that was in 1969. He come up with some theory related to this. But he did not become very famous or did not become very wealthy. But the same algorithm modified by Page, he is one of the wealthiest person in the world right now. So this is about graph theory. There are a lot of softwares for doing this. UCINet, PageRank, RGraph, iGraph. I'll just show one graph software for you and stop this talk actually. Okay. So how do you do this? How do you? Okay, let me. One software. There is a software called Gephi. Okay, so what you can do is go to Google and type Gephi. Okay, Gephi download. So this is a simple sort of free software. Gephi download. Gephi. This software you can do a lot of draw this beautiful graph and you can. So you click Delphi, and it's a file. You can download it in the bin folder. I'll show that folder also. Okay. In the folder Gephi that is there, then there is a folder called the bin, binary. You just double click this, then the software will open. So I'll just do this because I'm using a Linux software. Okay, let me try. Okay, so I'll use that actually. Okay, so Gephi I'll call Gephi. Okay, so the Gephi software will open up. This is a graph. Then you can open a graph, undirected graph. Okay, so see the graph. We can do a lot of analysis. Suppose if you want to know how many nodes, how many degree it has got, there is something called statistics here. You just find average degree, run it. It will show all this. Then on top you have overview, data laboratory, preview. 3 tabs are there. Click on the data laboratory. It will give the degree of each node. Each node, what is the degree, it will give. You can export this as an Excel file. You can do that actually analysis. So this Gephi software people use. If you want a printout of this, go to preview, refresh this. It will be a beautiful graph. Beautiful graph. You can save this as a PNG file, PDF file, or any graph file. You can save this figure. You put in the thesis, like you can make a good presentation. Well, I mean, I don't have much time to tell all the features, but we can play around with this. Even in Facebook, there is a group called the Gephi group. In Facebook, many professors across the world, they put how did they use the software Gephi for doing their research work and all you can calculate. Graph density, if you want a graph of calculate of a graph, click on run. It will calculate the graph density. There are a lot of properties, structural property. They call it as a structural property of the network. Then there is called a diameter. What is the diameter of the circle? In a circle, you have so many. In a circle, you have, In a circle, you have so many diagonal, no? Diagonal. Or add what you call code, I think. Code, different codes. This is the diagonal is the largest chord, right? Diameter is the largest chord, right? Similarly, find the distance between two nodes, distance with these two nodes, distance with these nodes. The largest distance is the diameter. That and then you don't have to do. You can just click here, it will calculate for that actually. Just click it, it will find the diameter. So this network has got a diameter 5. That means two nodes are connected, then the distance is 1. If for this one is maybe 2, like from here to here, we can do that. And you can do a lot of things. Here you can take this to make it large, this. Then here, a node, this one, you can click here, type the name of each node, you can here. Lot of analysis you can do with the software. You can remove nodes also, like find the main connected component, etc. How many nodes are there, how many edges are there, you can save it. So this is a very good software for doing as a preliminary analysis for the graph, actually. Beautiful graph you can do. And finally, then 3 tabs are there. Details are in this one, actually. You can export it as a graph, as an Excel file. In preview, you will get all kinds of figure. We can export this. You play around with this. You will learn this software. It's simple and free software. You can freely download. I think this is enough, no? Too much of anything is not good. I mean, my idea not to give all the proof or anything. My idea was to give an overall introduction to the youngsters, like what you can do with the graph theory. Okay, so it's something like applications of mathematics. See how much application you can do with the graph theory. If you think about that, the graph theory is only one subject of mathematics. There are a lot of subjects. So how are they applied? Yeah, for students, actually, you go to Google, find one application of what you do. You take one concept in mathematics and find an application. I mean, when you build walls, when you build walls, how do you build a wall? How do you build a wall? Like, so they want a right angle. How do you know that these masons, when they construct, then when the masons construct the wall, actually it should be diagonal, right? How do the masons know? So I'll show you example. Say in a wall, so this is one wall and this is another wall. Usually they built a room like this, maybe a door over here, like. So they want to know this is 90 degree, right? 90 degree. Have you ever, to measure the 90 degree, the mason should have a protractor, right? Have you ever seen masons are taking a protractor? No. But how do they measure the angle? What they will do is, usually, they will take like this. They will take three steps up to this. This is 3, right? And maybe 4 up to this cycle. This is 4 feet, right? Then if you draw a triangle, it should be 5, right? It should be 5. So 3 square plus 4 square is equal to 5 square. Now, this is, by the way, 3a square plus b square, okay, is equal to c square. Equal to c square. If and only if this angle is 90, right? If and only if 90. Which part they are using? If it is 90, If it is 90, right? If it is 90, then a square will be a square plus b square will be c square, right? A square plus b square will be c square. If it is 90, but they want to know whether it is 90 or not. What they will do is they will adjust, they will move like this, they will move slightly this side, and finally, when they become, it is exactly 5, they will stop. So they will measure it each time. When it becomes 5, they will stop it. That means Pythagoras theorem. So they are using this side actually. If and only the second part of if and only if they are using. If it is a square plus b square, then it must be 90 degree. That is how they measure. Actually, measures are using this theorem. I mean, we study a lot of if and only if theorems, right? So we might not have understand the beauty of it. Like, here, actually, in this theorem, if and only if they are using the other part of it, not the a square plus b square is equal to c square, if and only if it is the angle is 90, right? So they use the one part of it. See the application, it's a typical concept. Even masons are using to build their room, like the mathematics. Otherwise, they should have taken a big protractor with them every day. Okay, just nice talking to you all about all these concepts. And നിങ്ങൾക്ക് എന്തെങ്കിലും സംശയമൊക്കെ ഉണ്ടെങ്കിൽ ഫ്രീ ആയിട്ട് ചോദിക്കാം. എന്തെങ്കിലുമൊക്കെ ഉണ്ടെങ്കിൽ ഇതുപോലത്തെ എന്തെങ്കിലും കാര്യത്തിൽ ഹെൽപ്പ് ഒക്കെ വേണമെങ്കിലും ഞാൻ ചെയ്തുതരാം. നിങ്ങൾക്ക് കോൺടാക്ട് ചെയ്യുക, ഫോൺ വിളിക്കുക എന്ന് ചെയ്യുന്നതിൽ വലിയ പിന്നെ മടിക്കേണ്ട കാര്യമൊന്നുമില്ല. ഞാൻ പറയുന്നത് നിങ്ങൾ BSc പഠിക്കുമ്പോൾ തന്നെ ഇപ്പൊ നെറ്റ് ഉണ്ട്, എല്ലാ കാര്യത്തിനും നെറ്റിൽ നിങ്ങൾക്ക് യു ക്യാൻ ആസ്ക് ക്വസ്റ്റ്യൻസ് ഇൻ നെറ്റ് ആക്ച്വലി. സോ ഇന്റർനെറ്റ്, ഗൂഗിൾ ഇറ്റ്, ഗെറ്റ് ഐഡിയ. ഐ വിൽ ആൾസോ ആസ്ക് വൺ ക്വസ്റ്റ്യൻ ലൈക്ക് -1 റൂട്ട് ഇല്ല. 20, the root of 25 is 5, root of 16 is 4, root of 9 is 3, you know. What is the root of -9? No root, it is imaginary number, right? So we say that -1 does not have root, the I. Your teacher, even I am a teacher, like when I teach complex numbers, I say -1 does not have a root. So we represent it as I. So when you take imaginary number and complex number, you have a real number, you have a complex number like a plus ib, 4 plus 3i, like complex number. Immediately after, we will teach theorems after theorem, like Cauchy-Riemann condition, this condition, we will prove 250 theorems. What is your genuine doubt? Why all these theorems? But even after proving all these theorems, you cannot get the root of -1. Do you have a root of -1? No. Even now, -1 did not have a root. -1 does not have a root, -1 will not have a root. Then why the hell all these 240 theorems? Okay, search on net and find out an answer. It is there in the net actually, internet. You simply have to search introduction, historical evolution of complex numbers. It will give all the history. Why theorem? Without, you may say that it has got a lot of application in electrical engineering, complex numbers. Find an application in electrical engineering of complex numbers. If you do that, you will really appreciate the beauty of mathematics. Isn't it? Try that. With that, I'll conclude. Thank you for your patience listening to this. I was continuously talking, and thank you very much. Thank you very much for your patience. And if you have any doubts, feel free to ask actually, or doubt or interaction. If you know something also, you can share your knowledge also. Feel free. And മലയാളത്തിൽ എന്തെങ്കിലുമൊക്കെ ഉണ്ടെങ്കിൽ, എന്തെങ്കിലും സംശയം ഉണ്ടെങ്കിലും പറയാം, എന്തെങ്കിലും ചോദിക്കാനൊക്കെ ഉണ്ടെങ്കിൽ. Okay, thank you very much. Thank you again for the college for inviting me. It is my college. I was there for 5 years. So very nice talking to you all, like in the same college. And I think 2 years back, I came over there. I went around the campus because 5 years in a campus means a long period, right? Especially when you are very young. Thank you for calling me again. Okay, thank you. Thank you. Over to you.
Next is a doubt clearance section. Any doubt? In chat box.
You can, either put in chat box or you can use your mic and ask. There's no problem.
Vishnupriya has a doubt.
Okay.
Please unmute.
Sir,
Sorry, Vishnupriya. Sorry.
Hello, sir. I am Vishnupriya.
Yeah.
From St. Jude's College, Tuttur.
Okay.
സാർ ഗഫി ആപ്ലിക്കേഷനെ കുറിച്ച് പറഞ്ഞായിരുന്നല്ലോ.
അതെ.
അപ്പൊ അത് വന്നിട്ട് സിമ്പിൾ ഗ്രാഫ്, എക്സാമ്പിൾ <10 നോട്ട്സ് ഒക്കെ ഉള്ള ഗ്രാഫ് നമുക്ക് അതിൽ വരയ്ക്കാൻ സാധിക്കുമോ?
Yes, you can draw this actually. Even 10 nodes, even large node, you can draw.
Example, flower graph, wheel graph.
Yes, you can draw. Anything you can do that. And there is some more thing. How do you put a graph? അതെ ഓക്കെ. ഇതിൽ ഇടുന്നതിന് ഒരു രീതിയുണ്ട്. അങ്ങനെയും കൂടെയാണ് അത് നമ്മൾ ഗ്രാഫിന്റെ പടം വരച്ച സോഫ്റ്റ്വെയർ ഇടാൻ പറ്റില്ലല്ലോ. അതിന് നമ്മളൊരു പല രീതിയുണ്ട്. ഒന്ന് എഡ്ജ് ലിസ്റ്റ് ആയിട്ട് അതിൽ കൊടുക്കണം, അല്ലെങ്കിൽ അഡ്ജസൻസി മെട്രിക്സ് ആയിട്ട് അതിൽ കൊടുക്കണം, അല്ലെങ്കിൽ പേജെക് ഫോർമാറ്റ് എന്ന് പറഞ്ഞൊരു ഫോർമാറ്റ് ഉണ്ട്, paycheck.net ഫോർമാറ്റ്. So you have to convert that graph into this format and put in the software.
Okay. Thank you, sir. Thank you.
There are a lot of softwares, not Paycheck alone. This alone. There is another software called Paycheck. PAJEK. Another software. That is also a good software for doing this kind of analysis. Then R package. R is a statistical data analysis package. That also has got a lot of packages like iGraph, SNA, kind of thing you can do.
Okay, thank you, sir. Thank you.
Any other comments or suggestions? If you know, also you can tell something your opinion on. എന്തെങ്കിലും നിങ്ങൾക്ക് പറയാനുണ്ടെങ്കിലും പറയാം. അത് മടിക്കണ്ട.
Any doubt?
Otherwise, we will wind up.
Sir, the talk was very informative, sir. As the students don't know where to apply the mathematics, you briefly said the application and where we can put all these theories. It was very informative, sir. Thank you.
Thank you, Abhisha. Yeah. Dr. Abhisha was asked, did your PhD in our department. Thank you, Abhisha. We have to motivate the students by saying this application. Otherwise, they may find in dark. Now we have a lot of theorems, definition, and what's the use of these theorems? What's the concept of this proving this? And we have to say even the proof. Whether you can, by proving something, is it a real proof? That also we have to say. We have induction method. No, I'll tell you a story if you are interested. Like, there's mathematical induction theory. One question also was whether mathematical induction theory that their proof is correct or not. One mathematical professor put an example like, if you plug in one hair by one hair of a head, actually we assume that if you remove one hair from your head, you will not become bald. Just one hair if you remove from your head, you will not become bald. So it is true for one. Then you assume that n minus one hair, if you remove from your head, you are not bald, right? Then if you remove one more, you will never become bald. Just removing one more, you won't become bald. Then by mathematical induction, it should be true for any n, no? So you keep on removing hairs from your head. Won't we become bald? So is it the mathematical induction method? Is it correct? This is not my example, an example of a mathematician. Right? Okay, very interesting stuff and all there. And mathematics is very interesting. Mathematicians can learn any other subject, but others it's very difficult to learn mathematics. And a lot of applications, even in polymer science, and there are a lot of different equations, etc. being used. Okay, thank you again.
Thank you, sir. നല്ല സെക്ഷൻ ആയിരുന്നു. നമ്മൾ എപ്പോഴും തിയറി ഒക്കെയാണ് പഠിപ്പിക്കുന്നത്. അപ്പൊ കുട്ടിക്ക് തിയറി കേട്ട് മടുത്തിരുന്ന ഒരു സമയത്താണ് സാറിന്റെ ഒരു ആപ്ലിക്കേഷൻ ലെവല് നല്ല ക്ലാസ് ആയിരുന്നു സാർ. കുട്ടികൾക്കൊക്കെ ഒരുപാട് പ്രയോജനപ്പെട്ടു.
താങ്ക് യു
സർ. Next, I invite Dr. Murugan for the thanks.
Respected Principal Dr. K.C. Preetha Teacher, SN Trust Executive Member Aji SRM Sir, today's our Chief Guest Dr. K. Sadish Kumar Sir, IQC Coordinator Dr. Soju Sir, former Principal Dr. Jolie Teacher, Mathematics Department HOD, Nilima Teacher, Dr. Sanmat Teacher, my colleagues and dear students. It was a wonderful day for us. The lecture delivered by our eminent Professor Dr. K. Sadish Kumar Sir on complex networks enriched our visitors of knowledge. It was a wonderful experience for all of us. I consider this as an opportunity to thank each and everyone who have worked for making this webinar a great success. First of all, I would like to thank our most respected principal, Dr. K.C. Preetha teacher, for providing all the facilities and support for conducting a webinar like this. On behalf of the Department of Mathematics as well as on my behalf, I express our sincere thanks to you. Then I would like to thank Sri Aji SRM sir, SNCV executive member, for giving us support all the times. On behalf of the Department of Mathematics and on my own behalf, I extend our sincere thanks to you, sir. Words are insufficient to express our gratitude to Dr. K. Sadish Kumar sir, Associate Professor and Head, Department of Future Studies, University of Kerala, for his speech on complex networks. On behalf of the Department of Mathematics and on my behalf, I extend our sincere thanks to you, sir. Thank you, sir. Thank you, sir. I also thank Dr. Soju sir, IQC coordinator, SN College Vigri Varkala, for giving us all the help and support. Thank you, sir. I must say a word of thanks to Dr. Jolie teacher, former principal, and HOD Department of Chemistry for her support. Thank you, teacher. In this occasion, I remember the effort taken by Neelima teacher, head the Department of Mathematics, for organizing the webinar and making this a success. I thank Neelima teacher for her sincere effort. Thank you, teacher. I also thank Dr. Sanma teacher and Arsena teacher, my colleagues in the department, for their effort in organizing this webinar. I thank Dr. Nandakumar sir and Sajesh sir for the technical support. I thank all the HODs, faculty members of SN College Vigri Varkala for participating on this webinar. I also thank all the teachers from other colleges who have participated in this webinar and make this a success. I thank all the students who actively participated in this program and made this a great one. Thank you, one and all. Thank you, everyone.
Thank you. I should actually thank you all. And somebody has asked for the PPT. I will send the PPT to Neelima teacher. She may share with you. Like, I shall email to her the PPT if anybody wants. And somebody has put in the chat box that they asking for this PPT. I will send it. Okay. Thank you. Thank you very much. Thank you.
Thank you, sir. Okay.